Hey guys, welcome back. So in this lesson, we're going to talk about global error handling. Now, error handling in C# is really done through what we call a try-catch statement. So I just typed try, pressed tab twice, and then we got this block of code, right? Try, do something, catch any error that comes your way, throw means crash the program. So just think about it. If you're not so familiar with what error handling is, outside of what I just showed you, just think about every time you use an application, when something goes wrong, it has some error, it does one of two things. It either just brings up an error message and says, hey, you know what you tried to do didn't quite work out, please try again, the program is still running. Or sometimes it actually just throws you out of the program. Hey, what you did was invalid, and then the program crashes and stops working. So that is essentially error handling. So you can either crash the program through that throw statement that I just demonstrated, or you can, carry out some action, show a message, let the user know, hey, something went wrong, please try again, and then they can try again. We would have seen that in the past when we made some modifications, and I think we're trying to get back bookings or the list of bookings. You would have seen that yellow bar come up, and we had to go into the console and read through the error and then try and debug and try and fix and find out what was wrong. Obviously, you wouldn't necessarily want that kind of user experience for your actual user. It's okay for you as the developer because you need to fix it, but when the user is using the program, you don't want them to see reload and that yellow bar, something went wrong, and it's just a vague error. What we want to do in this lesson is set up a way that we can actually handle errors no matter where they happen in our application while writing as little code as possible. That's also key. Of course, take it in context because, code is not necessarily bad, but you don't want to have to be writing these try-catch blocks every time you're going to carry out an operation that has that API call. Because if the API fails, then our application will fail, as we've seen. But then we would have to write this try-catch in every single place that we would have been making an API call. And as you can see, I split out the logic and the Razor component files, and that would be quite a few places. All right. So you probably don't necessarily want to take that approach. It would work, but we're going to try it a different way. So what we're going to be doing to implement our global error handling is installing this package called HttpClient Interceptor. So we're just going to go over to NuGet in our client application, and we're searching for HttpClient Interceptor. So we go ahead and install toolbelt.blazor.interceptor. Now, after that has been installed, we're going to go over to our program.cs file, and then we're going to make a few adjustments, starting with our builder.services.add.http So I'm going to change this client here. I'm going to open and close parentheses, and I'm just going to put, for short, SP, and, well, we can put back the word client. So because we already have client working. So SP and client. And then I'm going to open a curly brace, open and close, but I'm going to open it first. And then after the client.base address definition, I'm going to close that curly brace. All right. Just work with me here. And then after this, we put a semicolon. And then we break line again. There we go. So we have, instead of just client, we have open and close parentheses holding SP, which represents the service provider, right? And then we have the client, which represents the HTTP client. And then we open the curly brace, and then we define what the base address is for the client. We don't change that line. The only thing we do is add a semicolon. Then we close the curly brace and close that parenthesis, all right? We don't modify this either, but inside of these curly braces, I'm going to also add client dot enable intercept. All right, and then this is going to need me to include that library toolbelt dot toolbelt.blazor extensions dependency injection. There we go. And then inside of that, we're going to put our service provider, which is SP, our service provider object, which we defined there. All right. and then we can set the semicolon there. And then after that, we're going to down a little bit more, just about here. This is good. We can register our intercept services. So we're going to say builder.services dot add HTTP client interceptor. So the purpose of the interceptor is to sit down and monitor all the API calls, and it will know whether it was a successful response or not before it comes back. So we've already kind of gone through what a success call looks like and what an unsuccessful call looks like in terms of the return codes, right? We know that 500, 400, those are not successful. 200 is generally successful. 100 and 300, those mean some amount of success, or the success has been reached, right? So what happens is that when you get a 500, something went wrong. The application itself, as we've seen, just gives a very vague, it doesn't tell you what exactly went wrong, or it doesn't let the user know, hey, technical difficulties, try again later. That's what we're trying to accomplish here. But the interceptor will be a nice, clean way of having that code being monitored all over without us having to write try catches everywhere. So after this, we have to create a code file to let the interceptor know how it should behave under what circumstances. So inside of the client project, I'm just going to create a new folder. I'm just going to call it services. And then in services, we're adding a new class, and I'm going to call it HTTP interceptor service. All right, HTTP interceptor service. And we go ahead and add that. And we're going to start off with a constructor. So we need to inject two things to be very specific. We need the HTTP interceptor and we need our nav manager. So we can just go ahead and put those into the parameters for our constructor. Go ahead and include any missing references. Now we can do a cool little thing here to get them actually initialized in the code without, manually writing it out like we have been doing. We can just click the light bulb and then we say create and assign field. So it will just automatically go ahead and create and assign the field and do that whole injection. So we can do that for both parameters, for both the nav manager and the interceptor. And notice I'm using field, not property, because it's private read only, right? By default, it doesn't come with the underscore. So I'm just going to put the underscores to, be consistent with the naming convention I've been using up until this point. But that's not much of a big deal outside of this method. You just use the this because they have the same names. So that's fine. We can move ahead now that we have done our injections. And the first thing that we're going to do is set up something like an event handler. On this, when this is called, we want it to continuously make another call to something. So it's like an event, right? So I'm going to say public void, let's say monitor event, right? And I'm just going to do that one line initialization and say interceptor dot, and then you see here are our events that we can set up, right? So I'm going to say after send and then do it like an increment. So after send meaning continuously, every time you're doing this, just make this function call. So I'm going to say intercept response. Once again, we want this is going to sit in between our client and the API call. So it needs to actually watch when a call is made, get back the response before the client, and then we're about to tell it what it should do when it intercepts the response. All right. So on intercepting a response, what we want to do is evaluate what kind of response it is and take an action. So I'll just generate the method for intercept response, private void intercept response, and we have the sender and the event arguments. If you've ever worked with WinForms or web forms, you would know all about these if you've never had to build them outside of that context, of course. But let us continue. So what we want to do is have a message, and we can just make that an empty string to begin with. And then I want to say if E, so E represents the event or the response from the event, the outcome of me trying to do something. So E dot, and if you look here, you'll see that you have access to the response and the request. So I can watch to see what was requested and watch to see what the response is. So I'm going to say if E dot response dot is success code. All right. So is success code means it's the 200, the 300, the 100, something that doesn't mean an error, right? Or, well, if you look at it by definition, it's really 200 to 299. Otherwise, it's false. So that's what success is. So I really want to do error handling, which means that if I want to really watch if it's not a success code, then I do something. All right, because then if it is a success code, then the application can run as normal. But if it wasn't a success code, then I want to spring into action. So I'm going to say var response code is equal to, and then we can just say e.response dot status code. There we go. And then we can have like a switch or if statement just to, go through the different options. So what if I wanted to do something if it was a 404 different from if it was a 500 different from if it was a 401, which means unauthorized and stuff like that, right? So you have different, if you want to make different or take different paths based on, oh my, look at that. That was an accident on my part, but look there, it's already giving you all of the status codes, which we probably really don't even need. We don't need all of these. So I'm just going to undo that. And the ones that we really want to focus on anyway would be case HTTP status code. And let me just take this off. HTTP status code and do any includes that I need to do. And then I want to maybe watch for 500 or, well, let's start off with the not found, right? So if it's a not found, then I want to take some course of action. Let me just put a break there. And let's say if it was maybe 401 or an unauthorized, you have unauthorized, and you also have forbidden, right? So if it's either one of these, then we probably want to show the same kind of message. And then the default, I'll just leave that to say that if it wasn't any of these, then just default to that generic error message page that says, something went wrong, please try again later, which would probably be like a 500. So I'm just showing you can get specific or you can just have that generic. So even if we didn't want to say take different paths, we could just say if it was not a success message or a success code, then do this. All right. So I'm going to put these back. And the reason we have the navigation manager, the nav manager injected, is that I want us to have different pages for the different paths that could be taken. All right. So I just went ahead and filled out the rest of it and I'll just walk you through. So we have the case for the not found. We're going to say navmanager.navigate to a page called 404, which of course we are going to create. This message is what will get displayed probably in the console of the browser. So we're going to have to throw something after all of this, but we'll get there eventually. So we go ahead and navigate to the 404. We log this to the console. If you're forbidden or unauthorized, we navigate to unauthorized. We also log this in the console, and then default, meaning anything else that was a failure, we just navigate to the 500 page, and then we say something went wrong, please contact administrator. Now, after doing all those checks, we're going to have to throw an exception. So we can just say throw new exception, and we're just going to pass in that message. All right. So that will kind of trigger the application to know that, hey, something actually went wrong. But once again, we can actually navigate to that page where we show the user a nice, friendly way that we handled the situation. Now, after doing all of that, we have one more thing we need to do where we need to dispose of the event. So we started the event where we're continuously calling this method to watch, and then we need to call dispose event where we're going to do the opposite. So here we were adding and accumulating. Here we just do minus equals. All right. So after doing all of that, we are going to have to register in our program.cs the fact that this service exists. So we'll do that underneath the add HttpClient interceptor, where we just put in add scoped and put in the name of the file, of course, include any missing references. And then we're ready to go ahead and implement this whole service. So let us go back to our index.razor.cs file. And what we'll do is let this partial class inherit from iDisposable. So this will actually give us a method that allows us to dispose of, well, any object that we don't want after its lifetime has gone. So usually what happens is that the dispose is called when the component goes on or when the component is no longer needed by the application. But what we want to do is put in some custom logic to dispose of our interceptor. So, well, before we can do that, let's inject the interceptor. So I'm just going to duplicate that line and I'm going to add HTTP interceptor. Let me just copy this interceptor service instead of trying to write it out. Go ahead, include missing references. All right. And then let me start off with the dispose. That's probably the easiest one to do. Here we just say interceptor dot, and we already have the method that says dispose event. So we can just go ahead and do that, right? Now, outside of that, we want to actually monitor what's going to happen. So right before we actually make our call, we can say interceptor dot monitor event. And that's it. So when we say monitor event, it's going to then start this method, which is now monitoring to see what is the response and what should it do afterwards. All right. So that is a nice, clean way of having something there to watch what is going to happen. So we can just do that everywhere we have a service call about to be made in as many files. And you see that this is much easier to put in than the whole try catch, because that would lead to a lot of repetition. So I'm going to do that again in the create. So I actually inadvertently put the code there without any injection. So let's do it from scratch again. One, I'm going to put in the iDisposable, implement that interface, and then I'm going to say, and you don't necessarily have to write the code in this order. I'm sure you know that by now, that you can write it in any order if you're comfortable with, as long as you follow the steps. So we have the interceptor being disposed. We have the interceptor monitoring the function, the API call here. And then the last part of this puzzle is just to inject it. And I'm just going to once again copy this line so I don't have to write it out from scratch, and voila. All right, so we're bearing down on completing this activity. Another thing that we need to do is to create the error pages, because we did say that we wanted a page called 404 to be navigated to, one called unauthorized and one called 500. So I just went ahead and created those components. 404, and it's nothing fancy, it's just a page with an H1 tag saying text dash danger, the resource you're looking for could not be found. It's navigational address, as you know, we have to say page slash the address, so that's 404. We have a similar setup for the 500, and we have unauthorized. And bear in mind, unauthorized, your components have to start with capital letters. So unauthorized is capital U, but the navigational address is fine as a common letter. That's up to you. I'm not putting anything too fancy in these components, but of course you can enhance them as your context requires. Now, in the colors controller, I'm going to put a not found right at the start of this method, where we, when the index page is called, it calls get colors, right? So, well, it calls the get and it tries to get the colors. So we're just going to return a 404 up front and see how this reacts. Right, so let us go ahead and look at the page for colors, and we're hitting the breakpoint, so we see that it should just return the 404. So I'm going to remove the breakpoint and press F5 for it to continue, and voila, the resource you're looking for could not be found. That is our 404 page. All right, of course we're getting this unhandled error because we threw that exception. If we look in the console, we're going to see that exception being thrown with the message, right? So it's up to you if you really want to throw that exception and, have this yellow bar loading, because that doesn't mean anything to the user, right? Not every user knows to go into the console and look at the error. So we could actually do without this throw new exception part at the end of the interceptor. And the interceptor really just handles everything gracefully for us. All right. So we could just say, navigate to this page, right? We could even enhance the components such that we just pass in the message as a parameter, so we don't have to write out the text manually. Once again, it's entirely up to you, but you have the concept now, so you can go ahead and implement this in your application. And it is a nice, quick, clean way to handle errors, because you don't know what might happen with the API. Something might get interrupted in a call, you get back a 500. Instead of writing too much custom code for every potential 500, we just write generic code, global code to say something went wrong, please try again, or please contact the administrator. It's entirely up to you.